Ethane has the formula C2H6. I'm going to do a Lewis structure for ethane. So keeping in mind it's made of carbon and hydrogen. Let's refer to the periodic table. Hydrogen has one valence electron. Carbon has 1, 2, 3, 4 valence electrons. So in this molecule we have two carbons with 4 valence electrons each for a total of 8. We have 6 hydrogens with 1 valence electron each. Gives us 6, a total of 14 valence electrons with which to build this molecule. Carbon wanting 4 bonds is going to be central, hydrogen around it. And when there's more than one carbon, our best guess is usually to put both carbons central and distribute the hydrogens symmetrically around those 2 carbons. So in this case, the 2 carbons are going to join to one another. The hydrogens, because they can only form one bond, can't be in the middle. They're going to be on the outside looking in. And so the carbons will bond to each other as well as to the hydrogens. So the next step is to join these central atoms to the outer atoms with electron pairs. And after we do that, we'll determine what kind of bond exists between the 2 carbons. Well, as you can see here, if I were to draw this using lines, each carbon at this point has around it 3 covalent bonds. Each hydrogen has the 2 valence electrons that hydrogen gets from covalent bonding. And that leaves us with the decision what kind of bond exists between the 2 carbons. It could be a single, double, or triple bond. There's no such thing as a quadruple bond. Here, since carbon already has 3 covalent bonds, it shares one more electron pair, forming a single covalent bond between the 2 carbons. Do a little bookkeeping here and make sure that our numbers work out. We have 8 valence electrons here. This carbon has an octet around it. We have 8 valence electrons showing around the other carbon. But total, that's 8 plus 6 more, 14 valence electrons. So we're in agreement with the valence electrons. We've fulfilled the honk rule. Hydrogen has 2 electrons and carbon has its octet.